This is Dr. Carroll, and today's video is about an introduction to inheritance. So, a background to inheritance. One of the major objectives of object-oriented programming is code reuse. We've seen this in building a function, which we can call over and over again, or a class, which we can reuse and have multiple instantiations of a class. We've really seen this with templated functions. That's why we templated them, so that we could reuse the code and change the type. We've seen it with templated classes, and now today we're going to see it with inheritance, which is we can reuse a class to build another class. So for an example, the university has been so pleased with how your lab's been coming. They'd like you to make a database for students, faculty, staff, administrators, volunteers, donors, alumni, contractors, etc. And so you're going to need to make a class for each one. And so for a student class, you'd have a first name, a last name, an M number, an email, what their year in school is, a major. And then for a faculty class, for example, you'd again have a first name, again have a last name, again have a M number, again have an email address, but additionally you'd have the department and if the faculty member's tenured or not. And then just to give one more example, an administrator, you would have they would have a first name, a last name, they would an M number, an email address all over again, and then they'd also have a title. So let's look at what an implementation of the student class would look like. Here we'd have the class student, would have several private data members, a given name, a surname, an M number, an email, their year in school, which we've provided as an enum here, and a major. So then you'd have a default constructor that did nothing. And then you'd have another constructor that takes each of those arguments, one for each private data member, and then assigns them here in the initialization list, one by one by one by one by one. Then we just threw in a little bit of code here to take care of the year, a little error checking. And then we have all the getters and setters, the get name, M number, email, year, major, and then all the setters for that. And it's a pretty straightforward student class. I named it old school because this is an old way how to do it. And you're thinking, oh my goodness, so you've already had the student class and you're trying to figure out how could you make all these other classes so that, but at the same time you're thinking, how many precious keystrokes is this going to cost me? Well, inheritance comes in to save the day and allows you to leverage existing code and intelligently deal with the complexity. So inheritance, like in nature, a child inherits attributes from a parent, and it's the same thing in C++. So let's nail down some definitions. First off, inheritance, what exactly is it? It's the relationship among classes, whereby a class derives properties from a previously defined class. Okay, so it's how the relationship between the class. Whereas the definition of base classes, it's a class from which another class is derived. Sometimes we call this the parent class. Well, that begs the question, what is the derived class? It's the class that inherits the members of a base class. Okay, and we often call that class the child class. Okay, so the purpose of inheritance is that it provides a method for coping with the complexity of a problem while allowing the use of existing code. So let's go back to our example. And remember, we're thinking code reuse. So what's the common denominator between the student, class, faculty, administrator, alum, contractors, and staff, all of those? What's the common denominator? That is each one is a parent, is a person. Each one is a person. And at a university, each person has a name, an ID, and an email address. And so let's take this old school student and let's copy it into a new file, a person file. Now there's some changes we need to make here. We need to change all the students to person. We can do that quick enough. Great. And then a person doesn't necessarily have a year and a major per se. So we're going to take those out. Take that out. And then year and major. And then there we go. We have our person class. And this is the base class. Okay? This is the base class. And that's all we needed to do to create the base class. Oh, there's one more thing we need to do. We need to change private to protected here, as you've heard about the last several semesters. That protected is for inherited classes. So if we want to be able to reuse these data members here, they need to be protected instead of private. Okay? Now that we have a base class, let's turn the student class that we have into a derived class. So let's save it as student.h here. And so what do we need to change? Well, the key thing is we need to inherit. So the way we inherit is we say public, then person. So this is where inheritance is going on. It's a public inheritance. We inherit publicly from the class person. It doesn't know about person, so we need to include it here. Person.h is what it was named. And then because of that, we don't need the names, the M number, the email address, because they are all protected and we have access to them as a derived class. And so we don't have to store them and use them in this class. So we can get rid of these getters and setters that are all the name, ID, and email address. Those are all, we inherit all of those. And so because we're a derived class. The next thing we need to do though is now we don't have a given name, a surname, an M number, and an email address. So what we do now is we call the constructor for the base class. We do that right here. So, and we typically do it in an initialization list. So instead of, I got that right. So here we call the constructor right here in the initialization list. Generally do it very first thing, and then we set the other items that are specific to our class. And there we go. Now we have a derived class. Okay? And think of all that code that we were able to reuse. Now what if we wanted to go ahead and make the faculty class? What would we need to change? What would be different between the student class and the faculty class? Well, the faculty class doesn't have a year and a major, but they do have a department and a tenure. And again, we would inherit from the person class. Let's take a look. So the faculty class here, again, inherits from the person class. Notice all it stores is the department and tenure as its private data members. It inherits all the protected ones that are common, the ones in person. Notice here we call person class and pass in the names, the ID, and the email address. And then we just have the getters and setters, which are specific to the derived class. Okay? Let's talk about another example. We've already created a stack class, we'll say. And what we need is a stack class that it has frequent reportings of the min and max values. So we have some options. We'll say we have 4 options. First, we could add min and max to our stat class that already exists. Now, a disadvantage is this, is we don't want to break existing code, and we probably don't need that functionality. So that may work, but that's not the optimal route we want to go for. Another option is that we could make a new class that has a stack object. Well, the relationship should be an is a relationship, not a has a relationship. And design should reflect reality, not implementation. Another option is we could copy and paste stack information into a new stack object and call it uber stack or min-max stack object. The disadvantage of this is then we would have code in 2 different locations, and if we wanted to update one stack object, we might not remember to update the other one. The 4th option is inheritance. We could have the stack class be the base class, and then we could have a stack min-max class which inherits it, and so we reuse that code in an intelligent manner that reflects the problem structure and add the new functionality in the stack min-max class, and there we go. Well, that's it for today's video.